Is the Earth really flat? This question has sparked debates for centuries. It's a question that has been asked by philosophers, scientists, and curious minds alike. The flat Earth theory, once widely accepted in ancient cultures, seemed to have lost its footing in the face of modern science. However, in recent times, there's been a resurgence of this theory, fueled by skepticism and mistrust of mainstream scientific consensus. Today, we find ourselves revisiting this age-old question, but rather than relying on hearsay or conjecture, we'll be turning to empirical evidence. We'll explore various scientific experiments, each designed to test the shape of our world. From observing the horizon and shadows, to assessing the flight paths of airplanes and the effects of gravity, we'll delve into the science that seeks to answer this intriguing question. So, is the Earth flat or spherical? Let's dive into the science. If you've ever been to the beach, you've unknowingly conducted a simple experiment. This experiment is known as the horizon test, and it's a fascinating way to observe the Earth's curvature. Imagine you're on the shore, watching a ship sail away. As it moves farther from the shore, it appears to gradually sink, disappearing bottom first until only the top of the mast is visible, and eventually it vanishes completely. This phenomenon is not because the ship is sinking, but because of the Earth's curvature. But let's delve into the science behind this. If the Earth were flat, the ship would simply become smaller and smaller until it's no longer visible, but it would not disappear bottom first. The reason we observe this phenomenon is because as the ship sails away, it begins to move over the curve of the Earth, which obstructs our view from the bottom up. This is where the science of light and our perception comes into play. Light travels in straight lines. When we look at an object, we see it because light from that object is reaching our eyes. As the ship sails over the horizon, the light from the bottom of the ship is blocked by the Earth's curvature before the light from the top, which is why the ship appears to sink. Now, let's consider perspective. Perspective is the way our eyes perceive the world around us. As objects move away from us, they appear smaller. This is why the ship appears to shrink as it sails away. However, perspective alone cannot explain why the ship disappears bottom first. For that, we need to consider the Earth's curvature. The Earth curves at a rate of approximately 8 inches per mile squared. This curvature obstructs our view of distant objects from the ground level, causing them to disappear bottom first over the horizon. So, the horizon test suggests a spherical Earth, but let's not stop there. Let's continue to explore this fascinating world we live in and keep questioning, observing, and experimenting. After all, curiosity is the fuel that drives scientific discovery. Ever noticed how shadows differ at the same time in different locations? It's a fascinating observation, one that was not lost on a Greek scholar named Eratosthenes over 2,000 years ago. In fact, he used this simple observation to conduct what we now refer to as the shadow test, an experiment that not only indicated the Earth's roundness, but also allowed him to calculate its circumference. So how did Eratosthenes do it? Well, he was aware that at noon on the summer solstice, objects in the city of Syene, which is now Aswan in modern Egypt, cast no shadow because the sun was directly overhead. However, on the same day and time in Alexandria, roughly 800 kilometers to the north, objects did cast a shadow. Eratosthenes made a rather brilliant deduction from this. If the Earth were flat, the sun's rays would come in parallel, and objects in both locations would have either no shadow or shadows of the same length. But that was not the case. The difference in shadow length suggested that the Earth's surface is curved. To ascertain the degree of this curvature, he hired someone to measure the distance between Siena and Alexandria. Then, he measured the angle of the shadow cast in Alexandria at noon on the summer solstice. The angle was about 7 degrees, a 50th of a circle. If 7 degrees corresponded to roughly 800 kilometers, then a full circle, or 360 degrees, would correspond to the circumference of the Earth. And voila! With some simple geometry and a bit of legwork, Eratosthenes was able to estimate the Earth's circumference with remarkable accuracy. Of course, his calculations were not perfect, but considering the tools and knowledge available in ancient Greece, it was a phenomenal achievement. So the shadow test also points to a spherical Earth, yet there's more evidence to consider. Next time you're on a plane, you could be conducting your own Earth shape test. Fascinating, isn't it? So let's dive into the airplane test. If you've ever had the privilege of flying, you might have noticed something intriguing. While cruising at a constant altitude, a plane can cover vast distances without ever having to adjust its altitude to compensate for any change in the Earth's surface. Now, if the Earth were flat, a plane flying at a constant altitude would eventually end up in space due to the lack of vertical curvature. But why doesn't this happen? Well, it's all thanks to the Earth's curvature and the laws of physics. As an airplane moves along its flight path, the Earth curves away beneath it, maintaining a consistent distance between the plane and the Earth's surface. This is why, despite covering large distances, the altitude displayed in the cockpit remains relatively constant. But let's bring some science into the mix. The force of gravity pulls everything towards the center of the Earth, including our airplane. As the airplane moves forward, gravity pulls it down, or more accurately, towards the Earth's center, which aligns with the Earth's curve. This downward force, combined with the lift generated by the airplane's wings, allows the plane to maintain a constant altitude relative to the Earth's surface. To put it simply, the airplane is continuously falling towards the Earth, but is also moving forward fast enough that the Earth curves away beneath it. This delicate balance of forces allows the airplane to maintain a nearly constant altitude throughout its flight, suggesting that the Earth's surface is indeed curved and not flat. So the next time you're up in the air, remember you're not just a passenger, you're a scientist conducting a real-time Earth-shaped test. Isn't that a thrilling thought? So far, all our tests suggest a spherical Earth. But let's look at one final experiment. Scene script. Have you ever wondered why everything falls straight down instead of at an angle? Welcome to the magic of gravity, a force that has baffled and fascinated scientists for centuries. It's this unseen force that keeps our feet firmly planted on the ground and causes apples to fall straight down from trees. But more than just an invisible tether, gravity offers compelling evidence that our Earth is not flat, but rather a round sphere. Now let's think about gravity on a flat plane for a moment. If Earth were indeed flat, gravity would pull everything towards the center of that plane, causing objects to fall at an angle as they moved further away from the center. In this scenario, buildings would not stand up straight but would lean towards the center of the Earth. But when we look around, we see that this isn't the case at all. Buildings stand tall and vertical, and objects, whether dropped from a skyscraper or a hand, fall straight down. So, how does this prove the Earth is spherical? Well, gravity pulls everything towards the center of mass. For a sphere, no matter where you are on its surface, the center of mass is directly beneath you. Therefore, gravity pulls you straight down. This is why everything falls directly towards the ground rather than at an angle. This observation isn't new. In the late 17th century, Sir Isaac Newton formulated the law of universal gravitation, which posits that every particle of matter in the universe attracts every other particle with a force that is directly proportional to the product of their masses and inversely proportional to the square of the distance between their centers. This law, which accurately describes the motion of the planets around the Sun, gives us a mathematical explanation for why objects fall straight down on Earth. This final test, like the others, suggests a spherical Earth. But what does all this evidence mean? We've conducted several experiments and the results seem pretty clear. Let's take a moment to revisit what we've discovered. Our horizon test showed us that the consistent disappearance of ships beyond the horizon can only be explained if the Earth is round. Then, The shadow test demonstrated that shadows cast by objects at different locations vary in length, a phenomenon only possible on a spherical planet. The airplane test further confirmed this by showing how their flight paths curved to follow the Earth's round surface. Lastly, the gravity test reminded us that gravity pulls everything to the center, causing a spherical shape. These experiments all point to one conclusion, debunking the misconception of a flat Earth. It's important to remember that science isn't about personal beliefs or opinions. It's about evidence and facts. So based on these scientific experiments, we can confidently say that the Earth is not flat, but indeed spherical. Science has spoken.